Welcome to third module. This module we are going to learn about modern periodic table. In the last module we have learned about the classification of elements based on the periodic law. Periodic law states that the properties of elements are the periodic function of their atomic masses. But later Henry Moseley showed that atomic number of an element is a fundamental property than its atomic mass. Accordingly, Mendeleev's periodic law was modified. Later, they formulated modern periodic law, which states that properties of elements are a periodic function of their atomic number. He said that the properties of elements varies atomic number, not with atomic mass. So the modern periodic table is in accordance with modern periodic law. He has arranged these elements in the increasing order of their atomic number. Children, last year we have learnt about atomic number, atomic mass, etc. What is atomic number? Yes, the number of protons present in an atom will give you the atomic number. The number of protons should be equal to the number of electrons present in an atom. Let us see how Mendeleev arranged the elements based on his modern periodic law. Children, this is how he has arranged the elements in his periodic table. Next, let us see the position of elements in the periodic table. This is the commonly used and long form of periodic table. Let us look at some features of the periodic table. First, groups. The periodic table has 18 columns are called groups. Extreme left end of the periodic table contains alkali elements or alkali metals, and the extreme right end contain noble gases or inert gases. All elements in the group has similar electronic configuration, and the group have the same number of valence electrons also. Next, let us see periods. 7 rows in the periodic table are called periods. In each periods, unusual shells are there. The period number is the number of shells present in an atom. For example, the elements belongs to first group has only one shell. We know that only hydrogen and helium has one shell present in the atom. So this belongs to first period. Then when you consider the second period, these elements contain 2 shells in it. Then third period, 3 shells, fourth period, 4 shells, and so on. Children, next let us determine the number of shells and the valence electron present in a sodium atom. We know that the atomic number of sodium atom is 11. Then what about the electronic configuration of sodium atom? Yes, 281. This is the electronic configuration of sodium atom that you can see in the picture also. 2 electrons are present in the K shell, 8 electrons are present in Lth shell, and the mth shell contain only 1 electron. So here the total number of shells present in the atom is 3. Therefore, it belongs to third period. Next, how will you identify the group number? Yes, you have to check the valence electron present in the atom first. Here, we know that the outermost shell of a sodium atom contains 1 electron. So, its valency is 1. Therefore, it belongs to first group. Children, as we go down in periodic table, within a group, elements have the same number of valence electrons, but as you go down a group, the number of shells increase. As the number of shells increase, the valence electrons are moved closer away from the nucleus. Thus, it will require less energy to remove an electron from the outermost shell. The energy required to remove an electron from the outermost shell is called ionization energy. So, the ionization energy decreases when we go down the group. Children, as you move down a group, the electronegativity of an element decreases because the increased energy levels or shells put the outer electrons very far away from the pull of the nucleus. So, the electronegativity of elements decreases when we go down the group. Children, if you look at the elements present in the second period, you will find that these elements do not have the same number of valence electrons, but they contain the same number of shells. You also observe that the number of valence shell electrons increases by 1 unit as the atomic number increases by 1 unit on moving from left to right in a period. So children, in this module we have studied that in modern periodic table, elements are arranged in order of their increasing atomic numbers. The vertical columns are known as groups and the horizontal columns are called periods. There are 18 groups and 7 periods in the modern periodic table. Next, elements having the same number of valence electrons are placed in the same group. For example, elements having valence electrons equal to 1 are placed in the first group. Elements having valence electron equal to 3 are placed in the 13th group. Elements are having valence electrons equal to 2 are placed in second group, except helium, which is placed in 18th group since it is an inert gas. Elements having the same number of shells are placed in the same period. Next is about the position of elements in the modern periodic table. Here, the elements are placed in groups according to their valence electrons and placed in periods according to their number of shells present in them.